Dear all, good day. Today is my lecture number 52, and the subject matter is squat calculations. Squat and UKC calculations. With respect to my previous lecture on the subject matter wide lecture number 3, as I had promised you and assured you, subjectively, and thereafter I got loads of query from my followers and even the candidates who are appearing for their orals, especially the mates and second mates, and sometimes masters, which has again motivated me to give you at length, elaborated, in-depth kind of knowledge, which may perhaps help you to persevere through your goals. Now, again, I would request you to please like, subscribe my channel, and press within bell icon so that you keep receiving the latest updates, because as and now I get time, I do upload all those lectures once I have accumulated all the queries and try to make it, in a conclusive manner. So please do like, share, and subscribe my channel under the banner of Marine Quest Solutions. So we begin with lecture number 52, squat and UKC calculations. Now, first and foremost, we must know what is squat and how does it affect the vessel. Squat effect is a hydrodynamical phenomenon by virtue of which a vessel moving through a shallow waters creates an area of reduced pressure that causes the ship to increase its draft and thereby be closer to the seabed than would otherwise be expected. So, this also I have explained in a diagrammatic manner as we go through the slides. So, the squat has few elements. One is that this phenomenon when the vessel is moving through the water, especially in a shallow water, which creates a reduced pressure, and that causes the ship to increase its draft and thereby be closer to the seabed than what we would have expected. However, make no mistakes, when sometimes the vessels are at anchorage and you have a very strong tide what you are stemming, still the effect of squat will be relatively affecting your vessel. So please do bear this in mind. Of course, that's a static kind of a scenario, that when your vessel is anchored and you're stemming a very strong tide, let's say ebb tide, which is always stronger, I've explained in my previous lectures as well, you will still experience the effect of squat. So be cautious about this aspect as well. This phenomenon is caused by the water flow, which accelerates as it passes between the hull and the seabed in confined water. As we go down the slide, you will see the clarity. The increase in the water velocity causing a resultant reduction in the pressure. As the velocity increases, the resultant, which results in a reduction of the pressure, which goes with the, because of the constriction between the seabed and the hull of the vessel. So the pressure reduces and the velocity increases. So squat, a hydrodynamical phenomenon, however, its effects gets more pronounced whenever the draft to the depth ratio is 1/2. In other words, if your draft, what I've explained, given kind of an example here, if your draft is 10 meters and you're entering into the depth of 20 meters or maybe a little more than that, the effect of squat starts working upon you. The pronounced effect of squat starts working upon you when depth to draft ratio is 1/2. In other words, your draft is 10 meters and depth is 20 meters. Now we all know that the calculation of squat, in open waters, that is OW, that is CBV square by 100, and in RW, restricted waters, it's 2 CBV square by 100. So the effect pronounced more exponentially in the shallow waters. The squat effect form a combination of a vertical sinkage and a change of trim and may cause the vessel to dip towards stern or towards bow. Now remember, one is squat, that is either CBV square by 100 in the open waters or 2 CBV square by 100 in restricted waters. But along with that, what is happening? You see, when I have explained in previous lectures the importance of underwater volume of displacement. Now, underwater volume of displacement has center of buoyancy. Now, conversely speaking, if I say that the center of buoyancy, if I construe it like center of gravity, because center of buoyancy reciprocatively is center of gravity of underwater volume of displacement. So when the vessel is tipping, the underwater volume of the displacement is also changing, and the center of buoyancy is changing. And because of that, you also may experience a change of trim. Besides the squat effect, because the vessel which is dipping by bow or by stern, the change in the underwater volume of displacement is changing. Because of that, there will be effect of change of trim as well. So I repeat this aspect again. The squat effect form a combination of vertical sinkage and a change of trim, which may cause the vessel to dip towards stern or towards the bow. We'll see as we go now. This is understood to be a function of block coefficient of the vessel, because block coefficient is very important. Whenever the second mates in particular, when you are calculating the squat, you must take the block coefficient with respect to your draft, which you'll find it in the hydrostatic tables. So the block coefficient, when you're making your squat calculation in a company's ISM, computerized tabular format, you must take the block coefficient for your existing present draft. Number one. Number two, the speed of transit shall also be concurred to in conformance with the master and of course the pilot, as the case may be. The vessel's CB, if the vessel CB is less than 0.7, she will squat by stern. So the vessels which have a fine coefficient or coefficient of fineness is very fine, like for example container vessels or cargo vessels which have a very fine bow, they will experience effect of squat by stern because of their block coefficient being less than 0.7. For tanker vessels, because of the bulb and broader bow, you will find the CB of the tanker vessel will be greater than 0.7, and therefore she will squat by head or by bow. So I repeat again, the vessels with a CB of less than 0.7, she will squat by stern. And the vessels with a CB of greater than 0.7, she will squat by head or bow. I hope this point has been, narrated clearly to me, to you all, by me. In case of any doubt, you can always come back to me. Now, before we proceed, because I've also shown the squat calculation, prior to that, we need to get our basics right, so therefore it's very important. So the other aspect which we must take into consideration is Catzoc. Now, Catzoc has 6 zones of confidence, which I've put it down in the slides. We'll talk about it one by one. Information about the Catzoc or zone of confidence helps in this. Based upon the error in the position and the depth, the accuracy of the data is divided into 6 zones of confidence, that is Catzoc. Each zone of confidence, Catzoc, has been assigned a maximum error that it can have in the depth and its position marked on the charts respectively. So we start with Catzoc A1, that is category A1 Catzoc. In this case, category, that is zone of confidence A1, the position accuracy is plus minus 5 meters. So the position accuracy in Catzoc category A1 is plus minus 5 meters. Depth accuracy, that is varying from 0.5 to like approximately 1% of the depth. And like for instance, if you see the position, the depth and the position and the accuracy of it, like for instance, if you have a depth of 10 meters, the accuracy will be plus minus 0.6. And if the accuracy is 30 meters, it will be 0.8. And if the accuracy is, if the depth is 100 meters, it will be plus minus 1.5 meters. And for 1000, it's plus minus 10.5 meters. So when the depth is 10 meters, the accuracy is plus minus 0.6 meters. And when the depth is 30 meters, it is 0.8 meters, that is plus minus. And for 100 meters, 1.5. And likewise for 1000 meters, 10.5 meters plus minus. The other thing is the seafloor coverage. The full area search undertaken, that is in this case of category A1 Catzoc, the full area search has been undertaken, all the significant seafloor features detected and the depths measured. So basically whenever they're doing the wire swept of the seabed or trying to do the the hydrographic survey, all these things are concurred to. Now typical survey and characteristics. The controlled systematic survey, high position and depth accuracy is achieved in this case using DGPS or a minimum 3 high quality lines of position, that is LOP, and a multi-beam channel or a mechanical sweep system. That's what I said, the wire swept, sweeping the seabed with a wire swept modus operandi. Now, in case of Catzoc A1, you'll find the 6 stars which will be marked on your chart. That is, when you superimpose your egg disk with the Catzoc, it will show you what is the how the data has been surveyed. If it is Catzoc category A1, then you will find 6 stars on the chart. That is, which is shown over here, 3 and 3, 6 stars over here. Coming to category A2 Catzoc, that is A2, and the position accuracy is plus minus 20 meters. And in this case, the coefficient is 1.00 plus 2% of the depth, which has been stated here in the tabular form. That is, if the depth is 10 meters, the accuracy is plus minus 1.2. So now here you see, with respect to Catzoc A1, it was 0.6 with 10 meters depth. But in this case, that is category A2 Catzoc, 10 meters is plus minus 1.2, almost doubled up. With 30 meters is 1.6, again it's already doubled up. With 100 meters is 3 meters, and with 1000 meters is 21 meters. So it's double the effect of the position accuracy and with respect to the depth in meters. The position accuracy and of course the depth, I mean to say. Now the modus operandi of this, like how it is performed, that is full area search undertaken, all the significant seafloor features detected and depth measured. However, the survey, typical survey characteristics are: the controlled systematic survey achieves position and the depth accuracy less than Catzoc A1, which has already been narrated, and using a modern survey echo sounder and a sonar or a mechanical sweep system. So, in category A2 Catzoc, you will find 5 stars, that is, which is shown over here. 5 stars will be there, so you know you are in category A2 Catzoc. Please do not undermine these aspects because this eventually affects your UKC calculations, which I've shown in my next slides. The third one is category B Catzoc, in which it is the accuracy is plus minus 50 meters, and the coefficient is 100 is to plus 2% of the depth. In this case, if the depth is 10 meters, the accuracy is plus minus 1.2, and if the depth is 30 meters, the accuracy is plus minus 1.6, and if the depth is 100 meters, it is plus minus 3, and if the depth is 1000 meters, it's plus minus 21 meters. Now how this survey is performed, basically going with the same, under the same tabular thing, that is seafloor coverage. The seafloor coverage in this case is full area search not achieved, uncharted features hazardous to the surface navigation are not expected but may exist. So it's a bit ambiguous. So when you're coming into category B, Catzoc, just as a navigator or to exercise prudence towards the safety of navigation, exercise due diligence for the masters and the officer in charge. Now, the next column is the typical survey characteristics, which is the controlled systematic survey achieving similar depth but lesser position accuracies than Catzoc A2. Of course, with comparison to A2, it is less accurate. Using a modern survey echo sounder but no sonar or mechanical sweep system. So you see how the provision of survey it has changed, maybe because of the depth or because of some constraints. In category B Catzoc, you will have 4 stars marked on the chart when you superimpose your egg disc with the Catzocs. Catzoc category C. Category C Catzoc, that is Charlie, and this is your position accuracies plus minus 500 meters. Your position accuracy is plus minus 500 meters, and going up to there, the depth accuracy is 2 plus 5% of the depth. 2 plus 5% of the depth. In this case, the depth, if you have a depth of 10 meters in category C Catzoc, then the accuracy is plus minus 2.5, 30 meters plus minus 3.5, 100 meters plus minus 7 meters, 1000 meters of depth, then you have accuracy of plus minus 52 meters. The seafloor coverage in this case is full area search not achieved. Depth anomalies may be expected. So depth anomalies may be expected. Many times, maybe because of the effect of global warming or the sea level recedings below the charted datum than what it was charted, you may come across seamounts. So be very careful. Even in the ocean passages, if you find something written seamount on the chart, just pass clear of it, because things may vary, the factuality. And as far as the accuracy of this category C Catzoc is concerned, low accuracy survey or the data collected on an opportunity basis such as sounding on the passage. So basically this is when the vessel is passing through the passage, is a sounding through the echo sounder. Through that, the data is collected and assimilated basis which the category C Catzoc has been laid down. And in this case, you have 3 stars, of course, lesser accuracy. Initially, we started with the category Catzoc 1, which had 6 stars. Then it came down to 5 stars. With Catzoc category B, it came down to 4 stars. Category C Catzoc, it came down to 3 stars. Category D Catzoc, that is worse than worse than Catzoc C. Of course, it's worse than that because here you have a depth of the depth accuracies, position accuracies plus minus 5 meters, and in this case, it's worse than Catzoc C. So it's worse than Catzoc C, what has been stated here, that is the depth accuracy, and the provision or the seafloor coverage, that is the full area search not achieved. Large depths anomalies may be expected. So this is what it is. One has to be very cautious if you're traversing through a category D of Catzoc, C of Catzoc, or B of Catzoc, because this is normally in waters where the accuracy of survey may be under a sign of interrogation. So the masters and the duty officers shall exercise due diligence. And what is the quality of this? The poor quality data, or the data that cannot be quality assessed due to the lack of information. Because of lack of information, lots of blind sectors or gray areas may be there. So the whole, the accuracy of depth could have not been accessed as far as category D Catzoc is concerned. And it is marked by 2 stars. Coming to the final one, that is U category, that is unassessed. That is, the quality of the bathymetric data has yet to be assessed. So I repeat again, under category U Catzoc, that is unassessed. The quality of the bathymetric data has yet to be assessed. So therefore, whenever you have U category, please do exercise caution and exercise due diligence. Now, coming to the point, as I've already mentioned in my previous slides, why is Catzoc important? And that's what we'll see. First, I'll read through it, then we'll talk about it. Knowing the meaning of the zone of confidence in ECDISC is a must for a qualified officer of watch. It is particularly important because the master and the OOW must always guarantee safety of navigation during the voyage or during the passage. For safe navigation, it is intended that the ship can sail from point A to port or point B without encountering any risk of grounding due to misleading information and or misinterpretation of the depth values from the master and or OOW in charge. And that is the reason on all the navigational charts where all the surveys have been, hydrographic surveys have been carried out, and the quality of bathymetric data has been assessed and evaluated. The Catzoc category have been marked, what we said earlier, in 6 categories. But the master and the duty officer shall exercise due diligence whenever they are traversing from one Catzoc to another, that is from higher to lower, that is from the initial one is that is from A1 to A2 and coming down to B, and thereafter. So if you're going from 6-star down the rung to, let's say, 3-star or 2-star, you have to exercise due diligence and be very cautious. That is what it means. And thereafter, whatever is the depth, whatever is the accuracy in the depth, as which is stated here, the depth accuracy is plus minus in 0.6 meters. That is, I'm showing you the example in category Catzoc A. This also shall be included with respect to the depth in which you are navigating into the UKC calculation, which I've shown step by step as we go down the slide. So the accuracy of depth plus minus 6 meter, what I would do as a master, I don't know, because negative will put me below the datum. I would add up this 0.6 meters. That is in this case if I show. But if I go into category A2, let's say with the depth of 10 meters, it's showing plus minus 1.2. I would take it 1.2 positive side. So this is giving me additional buffer. Now, conclusion. ECDISC zone of confidence represents 6 parameters on which the level of accuracy of the depth is determined. The Catzoc has been integrated into the modern ECDISC to facilitate the work of the officer of watch during the voyage planning, giving the ability to read with more veracity and with more valuable data, an adequate level of accuracy from the specific area, that is the area of navigation, area in which you're navigating. The zone of confidence in the ECDISC is significant, especially during the calculation of the UKC required while transiting in the shallow waters zones. That's what I said. The last thing what you need to do, basis what I've shown the UKC calculation, how it should be done, the additional aspect which should be included into the UKC calculation is your Catzoc. That is the area in which you're traversing, for which you're calculating the UKC. This is very important and it has become imperative. So now we talk about how does the squat works. If I talk about the ship is moving, and she, let's say, has a block coefficient of more than 0.7. She is basically, tipping down with the bow, that is, the block coefficient more than 0.7. So she's squatting by head. So there is a low pressure created here. And what happens? Increase in the forward draft along with the change of trim. Do not undermine the effect of change of trim. So what happens? In case you are in a depth ratio of 1/2, that is what I explained earlier, that is in case your draft is 10 meters and depth is 20 meters, of course you will experience a pronounced effect of squat by then. So what all the precautions and what all are the indications you may perhaps encounter if you go to the depth shallower than 20 meters, that is in this particular example when I said 10 meters draft and 20 meters depth. First is increase in the forward draft along with change of trim, that is with the vessel with the block coefficient of more than 0.7. A vessel with having a block coefficient more than 0.7 will squat by head, and a vessel which has got a block coefficient of less than 0.7 will squat by stern. So I repeat again. First is an increase in the forward draft for a vessel of more than 0.7 meter, more than 0.7 of the block coefficient. Increase in the forward draft along with the change of trim, sluggish steering, hunting of the gyro, vibrations and the hunting of tachometer. Now if you encounter any of these, that is change of trim will take place, of course, but the steering will become sluggish. Your gyro may start hunting even on hand steering, and vibrations and the hunting of tachometer, the engine room RPM tachometer may start hunt. So these are the indications that yes, you're coming into a shallower depth than what you expected. So also keep a check regularly and monitor your echo sounder readings and compare them with respect to the depths which are marked in chart. Of course, the height of tide is another element which I have talked about in the next slide. Now, how does it happen and why does it happen? I've just tried to explain in a nutshell. In case you guys have any other further query, I'll probably broadcast another lecture, explaining the Venturi effect at length. Venturi effect, the velocity of fluid passing through a constricted area will increase with decrease in pressure. Here the velocity has increased because the pressure has reduced. So it is giving not only buffer but the same amount of liquid is passing, because until here it's a high pressure area, but when it comes under the hull, the velocity increases and the pressure reduces. Because the pressure reduces, the bow tips more towards the seabed. Hypothetically, in case the pressure was more, the vessel would have not squatted. But this is not the phenomenon. This is by Bernoulli's theorem or the Venturi effect or the suction effect. Now, other element is greater the speed, more the time it takes to fill up the vessel's underwater volume of displacement. Now, when I say the magical word is underwater volume of displacement, I have already broadcast in my first few lectures to give you a complete kind of a cognizance and explanation so that you understand the importance of this. So if the speed is more, the more time it basically takes to fill up the void. Why? Because there's a constriction, number one. Number two, the channel width also matters, because the water is flowing, water finds its own place on space. But because of the draft of the vessel, the width of the channel, and the squat effect of the vessel with respect to the speed, the void or the underwater volume of displacement takes time to fill up. And that is where you experience this Venturi effect. So I repeat again, greater the speed, more the time it takes to fill up the vessel's underwater volume of displacement, especially in the restricted waters. and in return enhances the effect of squat. So, when you are in the shallow waters, of course, master, duty officers do exercise due diligence is that control your speed, and that is the reason when you, especially second mates, when you make the squat calculation, the speed is the main factor, and that is to be strictly adhered to. Vessel may experience vibration, sluggish steering, yaw, hunting of gyro due to the effect of suction, squat effect, and the venturi effect all combined together. And when I talk about the change of trim, if I take the underwater volume of displacement of this vessel, because let's say she's tipping by bow, let's say the center, she was at even keel with respect to static draft. Let's say if the center of buoyancy is here, and when she's tipped by bow, the center of buoyancy will change. So the center of buoyancy probably has moved little aft. Because of that, this fulcrum effect has increased. The fulcrum, that is the distance between bow and the CB, now with the effect of squat. Let's say originally she was here, now she has gone this way. So the effect of squat will increase because of the fulcrum, the tipping edge. So because of the fulcrum, the bow will tip more. Of course, the pivot axis is here, but then because the bow head is heading more towards the seabed in case when the block coefficient is more than 0.7 squatting by head, your pivot axis, which has a less leverage of fulcrum from the bow, will make your steering quite difficult. And that's what I said, gyro, hunting, vibrations, etc. Now we come to the final slide. I've taken an example that is for squat calculation and explanation. This is an example. Let's say the static draft of the vessel is 10 meters. Okay? That the static draft when you are at the berth is 10 meters, and the speed of transit in this case, let's say, has been decided as 10 knots. I'm giving an example. With respect to the speed of transit of 10 knots, let's say this is an example I've given, to make us understand, because speed is a very important factor. So let's say static draft is 10 meters with the speed we have taken as 10 meters in this case, a round figure for us to understand this very clearly. Static draft 10 meters, the squat allowance as per your calculation is coming, let's say 2 meters. So the dynamic draft in this case becomes 12 meters. It is to be added. Thereafter, the effect of weather. Now, weather effect, you do get weather report like, the sea or swell is 2 meters, you take the higher side, and this aspect also has to be added. Why? I have explained here. Because it is basically a sinusoidal curve, and this black line what I've shown where I'm, putting my pointer is one single wavelength. Let's say at one point in time, your vessel is somewhere here where I've marked with red on top. Do not get disguised, because if she has gained 2 meters and when the swell goes down in a sinusoidal curve, she may also come down. And if your UKC is not much, there is a probability that you may hit the bottom, and that is going to be catastrophically dangerous. So, this is one single wavelength. Amplitude in this case, that is the height of, let's say, sea or swell is 2 meters. And if the amplitude here up is 2 meters, down also will be 2 meters. And this is one single wavelength. So you can understand if you're sitting here and by mistake you subtract this because you realize that you're getting extra above the datum, then it's a mistake. The effect of weather shall be also added. So when I take effect of weather, as per the weather report, initially we started with 10 meters EK at the speed of 10 knots speed. The squat allowance has come to 2 meters, and your dynamic draft has come to 12 meters. Thereafter, effect of weather, let's say 2 meters, what is shown in your weather report, that also has to be added. So now the total becomes 14 meters. Thereafter, you allow for the height of tide. Let's say height of tide is 2 meters. That is to be subtracted, and you come back again to a figure of 12 meters, because height of tide is giving you additional rise above the datum. So it has to be subtracted. Thereafter, you have dock water allowance, that is change in density. Let's say going from sea water to fresh water. Of course, there will be also the factor of change of trim. Do not forget that. So, all conclusively, if I take all the effects into consideration, again, I'm showing you as an example the factual things you'll have to see, calculate from your, the data what you have. So, the dock water allowance, that is, the dock water allowance with respect to your fresh water allowance. If the density is, you're going from 1.025 to 1 density, then it is a fresh water allowance. But if it is you're going to a brackish water, then you have to interpolate and calculate accordingly. I've taken a figure of 1.2 meters for your explanation. So, with the height of tide, we were at 12 meters. Now, with additional factor of dock water allowance, that is the density going from sea water to fresh water, we have come to 1.2 meters. This gives us a figure of 13.2 meters. That is 12 plus 1.2. Thereafter, effect of hog and sack. Bigger vessels have bigger hog sack, like VLCCs have up to sometimes around 50 odd centimeters. And Afra, Suez may have 35, 40 centimeters, so I've taken approximately 30 centimeters. For a smaller vessel, it may be lesser, 15 centimeters or 20 centimeters. You'll see when you check the draft marks, when you're fully laden or loaded, you'll be able to ascertain the hog or sag, which will also be reflected in your load indicator as well. So, with the effect of hog or sag, let's say I've taken additional amount, 30 centimeters. So then it gives us a figure of 13.5 meters. Thereafter, the effect of heel or list. Now remember, your heel depends upon your superstructure, your windage area. Let's say you are in ballast and the wind is very strong. So the vessel may heel to one side, or when you're turning, giving a harder helm to port or starboard, there will be heeling effect if you have the wind broad on. So, the heel effect is there, which is external, and the list effect is in case you develop a list. I've taken in this calculation a consideration of approximately 5 odd degrees list in case you have some, because of your internal distribution of weight, you've come to a list of 5 degrees, then I've taken an allowance of 50 odd centimeters. But under all circumstances, make no mistakes, that whenever you are in the critical passage, ensure, or at all times, this is a good seamanship practice, that your vessel shall always be upright. Change of trim does take place, of course, but as far as your list is concerned, always keep her upright. But this is adverse case situation in case you encounter a list of 5 degrees because of problem with the internal distribution of weight. Then I've taken an example of 50 centimeters. This is again to explain you that effect of heel and list both, together can affect your UKC. And that's the reason I mentioned windage area and the weather conditions. That is, if you're taking the wind broad on the vessel, the effect of heel will increase, and less is because of the unequal distribution of the weights on board the vessel. Now comes the company's UKC policy compliance. Let's say most of the companies, they say 10% of the dynamic draft. If I take 10% of the dynamic draft, that is, my dynamic draft initially was 12 meters, so it gives me 1.2 meters, which is also to be added. Now, this is the place where we come to the magical figure of minimum controlling depth, which is actually conquered to after you have applied for the Catzoc. As per the depth accuracy, if I take the first case, in 30 meters you have 0.8, because the example what I've taken, that if you're in depth of 20 meters, so I will take the higher side. Means I'm drawing 10 meters, I'm coming into the depth of 20 meters, I explained earlier, and the effect of squat will be pronounced. But to be on the safer side, I would take for depth of 30 meters, the factor is plus minus 0.8, and that's what I will add up over here. So, if I add up here 0.8, that is as per this, 30 meters in case of Catzoc category A1. So it's 0.1, 0.8 meters. Probably just to have additional safety factor, I may round it off to 1 meter, or if you take 0.8 meters, it is coming to 16 meters. Therefore, what the second mate should do, they should do the squat calculation first. Once they know that, okay, with Catzoc, in this case I have taken 0.8 meters, it is rounding off to 16 meters. That means with the speed of 10 knots, okay, with the speed of 10 knots, that is, your speed shall not change. It should not increase. Decrease is okay. That is safety factor for you. And with the draft of 10 meters, your minimum controlling depth with Catzoc is coming to 16 meters now. So the courses which are to be laid by the second mate in consultation and conformance with the master shall be always above the 16 meter contours. In this particular case, I am repeating myself, so no mistake, no confusion takes place, that when your static draft is 10 meters and the master has decided that the speed we will not go more than 10 knots with this kind of parameters and configuration, and going into Catzoc A1, I've given an example. Your minimum controlling depth is coming to 16 meters. Therefore, the courses which are to be laid shall be above 16 meters depth, maybe 20 meters. More the merrier. So, finally, I've mentioned here the course to be laid on the nearest highest contour. That is for 16 meters. I'll be happy to lay the course above 20 meters or above, whichever is safer for me as far as the master's prerogative and master's perspective is concerned. So, ladies and gentlemen, I have explained in details the effect of squat, UKC along with the Catzoc. I hope it would have been of some help, because I had initially promised that yes, I will take this lecture further, because there have been a lot of mistakes which are taking place, which I've seen, lots of casualties are taking place, because many a times the second mates do not know what block coefficient is to be taken. They take, abruptly some block coefficient, whereas the block coefficient to be taken in coordination or with respect to your present static draft and the speed of transit. These are the very two important aspects, and Catzoc can also not be undermined along with the aspects what I've explained for UKC calculations. So, ladies and gentlemen, I hope I have been able to do some justice to this particular subject matter. I wait for your feedback. Thank you very much. Good day. Stay safe. I sign off.